Hello, welcome again to Math County. So last time we spoke about limits, derivatives, and integration. I gave a general introduction to all three subjects or topics, and then delve a little bit into the limits. So we spoke about the left and right limits, solved some examples, and then I spoke a little bit about infinite limits. But in this video, we are going to go a little into the infinite limits. So let's consider a function 1 over x squared here, right? Now, let's see what happens to this function as x approaches 0, okay? So we take limits as x approaches 0 of f of x, which is what? X squared, right? So what happens here? Let's consider some, some values. So say x, 1 over x squared. So considering that there's a square here, meaning whichever value we put in there being positive or negative, our outcome will be a positive answer. So let's say we have plus or minus 1. Let's find f of negative 1. That gives us 1 over minus 1 all squared. And this in turn gives us 1 over 1, which is equal to 1. So we get 1 here. So what if we put 0.5 plus or minus 0.5? So that means we are going to get 1 over 1 over 2. You know 0.5 is the same as 1 over 2, right? So we get 1 over 1 over 4, which in turn gives us 4. Right? Okay. So what if we have plus or minus, say 0.001? So we have 4 here, and this will in turn gives us a million. So as you can see, as the values of x approaches 0, the values continue to increase. The curve of this function, or the graph of this function, looks like this. So we have y here, x here, then we have 0 point here. Okay, it looks so from the left, this is how the function behaves. Now, since these two curves from the left and right never get to meet the vertical axis, we say the vertical axis is a what? It's a vertical asymptote to the two curves. Okay, so generally we have limit as x approaches a, f of x approaching infinity, because you can see that these values continue to increase up to a certain huge number. Okay, so that doesn't mean infinity is a number. Okay, the values increase and increase till without end. Okay, so that is why we say it approaches infinity. Okay, now, so generally we have limit as x approaches a, f of x equal to infinity, and the curve of that graph will look something like this. So we have y, x, we have an a line here. This value is x equals a. X equals a. So meaning this is a, right? Good. So we'll have a curve that looks something like this. Like this. Okay, great. So there are several instances where some graphs will have some vertical asymptotes. So for example, if we have a graph of a limit as x approaches a from the left, f of x equals infinity. Now this graph will look something like this. We have a here. Okay, so from the left we have the graph looking something like this. Okay, then let's have one more here. So b, we have limit as x approaches positive a from the right? F of x equals positive infinity. So we also have something like that. So from the right, y changes. Then going up, right? Good. And then we can also have, say, f of x as x approaches a from the left. From the left, f of x equals negative infinity. So this will in turn look like this. So we have a here, and then from the left, we have something like that. Okay, so it's approaching negative infinity. So this line, the line x is equal to a for all instances. Okay, for all instances, we say that the line A, the line is a vertical asymptote. Okay, so let's look at an example here. So example, let's say we have, says we should find lim as x approaches 4 of 2x all over x minus 4. Okay, so let's see what happens when x approaches 4 from the right. Okay, so from the right we have, let's choose for x 2x over x minus 4. So we have 4.1, and then 4.001. So if you have 4.1, for x to be 4.1, we have 4.1 all over 4.1 minus 4, and this will give us 82. So you have 82 here. And then for 4.001, we have 2 times 4.001 all over 4.001 minus 4, and this in turn gives it 8002. So we have 8002. So we can see clearly from this graph that as we continue to get close to 4, right? I just chose to use 2 points here. You can choose to use more points so that you can get a clearer picture. Okay, as we get close to 4, the values of f of x continues to increase. Right. So let's look at what if we are coming from the left. Okay. So if you are coming from the left, let's choose the value x. So let's say right. So for left, let's choose x equals 3.8, and then x equals 3.9. So for x, so let's just put it 2x minus 4. So for 3.8, going through the same computation as we did earlier, we have minus 38. And then for 3.9, we have minus 78. Again, as you can see, the value seems to be decreasing. And the more we go, the further we realize that the values approach negative infinity. So the graph of this function will look something like this. So we have a line here at 4. Okay, so from the left, we approach positive infinity, and then from the right, we approach negative infinity, right? So that is to say that from the right, we had limits approaching positive infinity, and then from the left, we had lim as x approaches for 2x over x minus 4 plus negative infinity. Okay, great. Again, another function that has vertical asymptotes is the natural logarithm. Okay, say we have y equals natural log of x. Okay, this also looks, sorry, I would like to bring it here, looks something like this. So we have y here, then x here, and it's going to look something like this. Okay, this function is also asymptotic to the vertical y-axis. Okay, so we'll leave it here and then we'll continue with the tutorials in another video. Okay, see you later.